Why are there so many different energy units? Imagine trying to compare the energy used to light a candle, power a rocket, or cook a meal. It's not as simple as just saying they all use energy because each situation needs its own way to measure it. That's why there are so many different energy units. Energy is the ability to do work or cause change. In science, especially in physics, the main unit used is the joule. 1 joule is the amount of energy when a force of 1 Newton moves an object 1 meter. It's a straightforward way to measure mechanical energy. But energy isn't just mechanical. It appears in many forms like heat, light, chemical reactions, or atomic processes. Because of this, different units have developed to suit each type. For tiny particles and atoms, scientists use the electronvolt. It measures the energy gained by an electron when it moves through an electric potential difference of 1 volt. This unit is perfect for understanding atomic and subatomic phenomena because the energies involved are very small. In everyday life, especially when talking about food or heat, people use calories and kilocalories. A calorie is the amount of energy needed to raise 1 gram of water by 1 degree Celsius. A kilocalorie, often called a food calorie, is 1,000 calories. This makes it easier to understand how much energy we get from eating or how much heat a substance contains. In the heating and cooling industry, the British thermal unit is common. It measures how much heat is needed to raise the temperature of 1 pound of water by 1 degree Fahrenheit. It's handy for describing how much energy fuels a furnace or heats a building. Energy units like the barrel of oil equivalent or ton of oil equivalent are used by energy companies and governments. They express the energy content of fuels in familiar quantities, like how much energy is in a barrel of oil or a ton of coal. These help compare different sources of energy on a large scale. The reason for so many units is partly historical. Different fields developed their own ways to measure energy based on what was most useful for their work. For example, atomic physics needs tiny units like electronvolts, while engineers working with engines prefer joules or calories. Also, each type of energy has a typical scale. Mechanical energy is often measured in joules, while thermal energy might be better expressed in BTUs or calories. Chemical energy, like in batteries or fuels, is often measured in joules or calories too. In daily life, this variety helps us understand energy in ways that make sense for each situation. When you see a food label, you're looking at calories. When you turn on your heater, it's probably measured in BTUs. When scientists study tiny particles, they use electronvolts. All these different units show how energy is everywhere and takes many forms. They help us communicate, compare, and understand energy in the context that makes the most sense for each use. That's why there are so many different energy units.